Sino ka?
Ba't tayo nandito?
Nandito ako. Imanap lang ako. Kasi,
Uy. Ano ka? Ay naman.
Sandali! Parang ikot-ikot na yan.
sandali.
Oh,
Yun lang kita.
oh.
Kaya sa lubog sa van.
Oo, ako yun. Ako
Ikaw
yun.
yung nagbigay nito.
Oo, ako din yung nagbigay niya.
Ako ibang shade.
Ako din yung dumaan sa kantin.
Ito ba surahan?
Oo, ako din yun. Ako lahat
Ikaw
yun.
nagbigay na naman.
Oo,
Ito
ako
yung
yan.
ganda. Ang ganda. Ang ganda. Hindi ka nga
So, bakit yung binigay ito?
Siyang dala na lipstick.
Hindi, gusto ko ibang shade.
Bakit hindi nilagay mo
Wait
sa
lang.
akin?
Tumahimik muna kayo.
Hindi, huwag kang malakasan.
Alam niyo ba kung bakit nandito kayo? At kung bakit meron kayo ng mga bagay na yan? Nandito kayo para sa isang mission.
Ay, parang,
Oo, isang mission.
mission.
Alam niyo ba na pinatawag ko kayo dahil ang hatid si Baby Boy ay nasa nakakalagayan ngayon?
Baby boy.
Baby boy.
Kasi yung tumawa, yung tumawa, siya talaga si Baby Boy.
Listen mo! Tagal mo
Bakit
ba?
ako itin?
Sa'yo pa ako.
Dito ko naman.
Kailangan ng inihihiya ng Baby Boy na to. At kayo pinatawag sa mission para magdala ng mga inihihiya na yun. Meron kayong pupuntahan ng bawat isang istasyon kung saan may mga problema doon at kailangan yung sagutan.
Pero bakit kami?
Tsaka paano namin magagawa yun? Estudyante lang kami.
Ordinary estudyante lang kami.
Kaya meron kayo ng mga bagay na yan at ang mga bagay na yan ay may mga kapangyarihan.
Is pa dyan. Uy, shadow kasi ganyan ako na. Hindi mo kasi nasabayan.
Masyado mo ginaganda.
Baka ito yung ano yun? Parang nainap.
Anong sabi ng lipstick?
What is the amount of charge stored per unit volt?
Wait. Ano ba yan eh? Wait.
Starts with that way?
Hindi.
Wait, parang C? Hindi, parang X? D.
Bakit si?
Kate.
Ka.
America?
Kapa.
Kapit?
Kapitan?
Kapansin?
Kapa.
Kapal.
Sing? Capacitance?
Hindi kapasitan.
Capacitance.
Capacitance? Capacitance?
Kapasitan?
Capacitance. Capacitance is the electrical property of a capacitor and is the measure of a capacitor's ability to store an electric charge onto its two plates, with the unit of capacitance being the farad, named after the British physicist Michael Faraday. Capacitance is defined as being that a capacitor has the capacitance of 1 farad when a charge of 1 coulomb is stored on the plates by a voltage of 1 volt. Capacitance of a parallel plate capacitor. The capacitance of a parallel plate capacitor is proportional to the area A in meters of the smallest of the two plates and inversely proportional to the distance or separation B, given in meters between these two conductive plates. The generalized equation for the capacitance of a parallel plate capacitor is given as C is equal to E quantity A over B, where E represents the absolute permittivity of the dielectric material being used. The permittivity of a vacuum, E, also known as the permittivity of free space, has the value of the constant 8.84 times 10 farads per meter.
Uy, tama! Ano yan?
Ano to?
Feeling ko.
Baka part pa lang yan.
Baka ito na yung simula ng mission. Baka kailangan natin buuin to.
Okay,
Kayo ba lang pinadala ni Gandarang mga sugo ni Baby Boy? Di ko ba kaya makalagpas niya dito?
wait lang! Tumakas na tayo!
Naamon kita sa isang paglalaban. Labas, labas, labas.
Teleport na lang tayo.
Kasi yung basic piece. Ay, yung piece na makuha ko. Parang hindi naman dito ba? Parang hindi dito. Bakit din ba? Hindi naman ba dito?
May kasama!
Dito lang. Hindi ko ganda dito ah. Hindi dito. Eh, siyempre dito dito. Di naman ano teleport natin. Guys. Guys, paano ko bababa dito guys? Guys. Hindi nakaka-stretch. Kung may lakas naman yung mga telephone, natin na ilaw. Ayun na.
What is the device that stores electric charge?
Battery.
capacitor is a device used to store electric charge. Typically, a commercial capacitors have two conducting parts close to one another but not touching. This is because of an insulator. Insulator is used between the two plates to provide separation. When battery terminals are connected to an initial uncharged capacitor, equal amounts of positive and negative charge are separated into its two plates. The capacitor remains neutral overall, but we refer to it as storing a charge in these circumstances. The amount of charge a capacitor can store depends on two major factors: the voltage applied and the capacitor's physical characteristics, such as its size. System composed of two identical parallel conducting plates separated by a distance is called a parallel plate capacitor. It is easy to see the relationship between the voltage and the stored charge for a parallel plate capacitor, as shown in the figure. Each electric field line starts on an individual positive charge and ends on a negative one, so that there will be more field lines if there is more charge. The electric field strength is thus directly proportional to the charge, and the voltage is also directly proportional to the charge. This is true in general. The greater the voltage applied to any capacitor, the greater the charge stored in it. Different capacitors will store different amounts of charge for the same applied voltage, depending on their physical characteristics. We define their capacitance to be such that the charge Q stored in a capacitor is proportional to the charge. The charge stored in a capacitor is given by Q equals to C V, or charge equals to capacitance times its voltage. This equation expresses the two major factors affecting the amount of charge stored. Those factors are the physical characteristics of the capacitor and the voltage. Rearranging the equation, we see that capacitance is the amount of charge stored per volt, or C equals Q over B.
Capacitor. Kinakita mo yung capacitor. Tama? Tama. Wala pa yung ginagawa. Capacitor. Capacitor. Wait! Hoy! Uy! Sa akin mo lang. Wait! Ayun ka lang pala yung sinasabi. Ayun na! Yes! Oh! Hindi ganun kadali yun! Ay, ganun na lang. Galing. Ito!
Kaya mo ba?
Kaya ko!
Sige ah. Tingnan lang namin.
Kaya ko!
Kapag.
Yes! Challenge! Mag-ingat ka! Ayan.
What do you call an insulating material?
Insulating metal.
Wait lang, alam mo yun, ayun yung property.
Copper wire. Insulating.
Paper. Copper. Alam mo yan. Yung
Copper wire. Metal.
parang may kasama electric. Ayan.
In most capacitors, a non-conducting material is placed between the two metal pieces that make up that capacitor. There's two reasons for this. For one, the non-conducting material prevents the pieces of metal from touching each other, which is important because if the pieces of metal near touching, no charge would ever get stored since you have completed the circuit. But there's another bonus to inserting a non-conducting material between the plates of a capacitor. It will always increase the capacitance of that capacitor. As long as the material is non-conducting, it doesn't even matter what it is. As long as you don't change the area of separation between the plates, inserting a non-conducting material will always increase the capacitance. The name we give to non-conducting materials placed between capacitor plates is a dielectric. But why does a dielectric increase the capacitance? To find out, let's look at this example. When you hook up a battery of a voltage to a capacitor, charge will get separated. Now let's say you remove the battery. The charge is stuck on the plate since the negatives don't have a path in which to get back to the positives. So even after removing the battery, the charge on the plate is going to remain the same, and the voltage will also remain the same as the voltage of the battery that charged it up. Now imagine placing a dielectric in between the plates of the capacitor. The dielectric material is made out of atoms and molecules, and when placed in between the plates of the charged up capacitor, the negative charges in the dielectric are going to get attached to the positive plate of the capacitor. But those negatives can travel to the positive plate since this dielectric is a non-conducting material. However, the negatives can shift or lean towards the positive plate. This causes the charge in the atoms and molecules within the dielectric to become polarized. To put in another way, the atom kinds of stretches and one end becomes overall negative and the other end becomes overall positive. It is also possible that the dielectric material started off polarized because some molecules are just naturally polarized like water. In this case, when the dielectric is placed between the charged-up capacitor plates, the attraction between the negative side of the polarized molecule and the positive plate of the capacitor would cause the polarized molecules to rotate, allowing the negatives to be a little bit closer to the positively charged capacitor plate and vice versa. So how does this increase capacitance? The reason this increases the capacitance is because it reduces the voltage between the capacitor plates. It reduces the voltage because even though there's still just as many charges on the capacitor plates, their contribution to the voltage across the plates is being partially cancelled.
In an insulating material, the term dielectric strength denotes the maximum electric field that a pure material can withstand under ideal conditions without breaking down, for such without experiencing failure of its insulating properties. For specific configuration of dielectric material and electrodes, the minimum applied electric field results in breakdown. Minimum electric field is the applied voltage divided by electrode separation distance. The theoretical dielectric strength of a material is an intrinsic property of the bulk material and is independent of the configuration of the material or the electrodes with which the field is applied. This intrinsic dielectric strength corresponds to what would be measured using pure materials under ideal laboratory conditions. There are few factors affecting apparent dielectric strength, namely, it decreases with increased sample thickness, it decreases with increased operating temperature, it decreases with increased frequency. For gases, like nitrogen, sulfur, hexafluoride, it normally decreases with increased humidity for air. Dielectric strength increases slightly as the absolute humidity increases but decreases with an increase in relative humidity. The unit of dielectric strength is volts per meter. It is also common to see related units such as volts per centimeter, megavolts
Saan ba tayo? Saan naman tayo yung teleport? Parang teleport na ng teleport. Mission. Kasi nga dito ang ganda. Kaya ang hangin mo dito. Tingnan mo nga yung laser mo kasi. Kung ano, kung ano na yung next na mission. Yun dito na ba? Ayun na.
It is a two identical conducting plates separated by a distance.
Ito dalawa.
Three plates.
Wait lang. Parang hindi kwento ka santa.
Hindi ko naman ngayon magkasama.
Parang nakasunod yung mission. Oh, di ba dapat alam mo yung mga wait na. Kaya mo na yan.
Three plates naman. So just
Parang
dalawa.
Dalawa.
Baka sana din.
Di naman kasi namin yan. Kasi parang plate capacitor. One, two, three, go. Parang plate capacitor. Kami naman doon ang sa akin.
Ayun na! Yung plates! Ayun na! Ayun na yan! Ikaw naman alam mo tayo yung plates na doon. Sabihin ko capacitor kasi kanina.
Oh my God!
Capacitor na capacitor.
Parang nabuo na natin.
Oh my God!
Kasi nga, nabuo na natin, madam. Kasi nga,
Hindi na rin ako Kamusta natin yung paglalakbay?
mahirap ang teleport. Grabe naman ang teleport.
Ito na yun!
Pero nalala. Ayun na yun! Ayun na yun! Ayun na yun!
Pero naman, ito na magliligtas sa aking baby boy. Paano?
Excited na akong mabuhay si Baby Boy.
Uy, baby boy!
Asa na si baby boy?
Tayong lahat. Andun siya, nakapunta na.
Tara na, tara.
Ito na, mabuhay ka na. Saglit lang. Oh my God, baby boy! Sige, mabuhay ka na.
Ano nangyari?
Buhay ka na, baby boy!
Salamat.
Thank you to sa The Revenger Squad.
Here, I will explain how the incubator worked, thus making me survive the pit. At the very start, the incubator was connected to two plates, which both have an equal amount of protons but unequal in the amount of electrons. However, there is an insulator between the two plates. That means electrons will not flow through it. Let's say that the two plates have both 1000 protons, but one plate has 1200 number of electrons, and the other has only 800. Of course, for a capacitor to be able to work, the voltage must be applied. Just a reminder, protons don't move but electrons do. The electron will move from the plate that has more electrons going to the plate with the efficient number of electrons. Let's say that 12 volts is applied. The electrons will then move through the wire towards another plate. As mentioned, the incubator is placed between the two plates, and upon reaching the incubator by these electrons, there was a kind of current that formed which caused the incubator to work. However, when the 200 electrons have already transferred to the other plate and attained equilibrium, there will be no more charge to transfer, thus no more current that will be created.
Ano dito?
Hirap na ako.
Saan?
Hindi mo ko naiintindihan eh. Kung hindi mo na ako magugustuhan, mas mabuti pa mamatay ka na lang din. Saan mo yan? Hindi ka makilala. Ako ang nagpadala sa'yo sa inyo. Kailangan mong talunin ang mga revenge squad. Kailangan mong pigilan ang pag-iibigan ng dalawa. Inaasahan kita na magagawa mo ito.
Ano